Okay, so welcome to this video. I want to honor a request that I was given by one of my students to do a question on reflection. Uh, Reflection comes from a topic of transformation, and the question is very specific here. We are told to determine the coordinates of P prime, the image of P 2, negative 3, under a reflection in the line y is equals to 2x minus 1. Okay, so I will do it very quickly because it's not a difficult question. Actually, when it comes to mapping, you only need to have what we call geometric intuition. So allow me to go down into solving this. So I want you to have a geometric interpretation of this one. If you take this one as our Cartesian plane, you forgive me, I will not draw it to scale. I'm just making a sketch here. Oops, sketch. So this is the origin. And I'm going to kind of plot the line in question. This is what we call the mirror line. The mirror line. Our mirror line is y is equals to 2x minus 1. So let me plot this line quickly. When x is 0, here y is negative 1. And when x is 1, y is 1, yeah? When you substitute those values here. So if this is my 1, 2, 3, 4, 1, 2, 3, 4, then my negative 1, negative 2, negative 3, like that. Then I have 1, 2, 3, and so on. So negative 1, negative 2, and negative 3. It's not drawn to scale, just to make a sketch so that we can have a clear illustration of what is going on here. So if you plot our line here, when x is 0, y is negative 1 at the point. When x is 1, y is 1. When x is 1, y is 1. So a point somewhere here. So my line is this. That's my mirror line. That is y is equals to 2x minus 1. Cool. Now we want to locate our object so that now from there we can actually use the facts that we already know to determine the image. So let us locate the coordinates p, which is 2, negative 3. So p is somewhere here. So this is my point p, that is 2, negative 3. So p being here, you know one thing, when there is a reflection on a straight line, the distance of the object from the mirror line is the same distance from the image to where the mirror is. All right, so we can say the distance from here to the center, or to where the mirror is the same distance from where the mirror is to where the image is. Actually, that tells us something to do with orthogonality of the lines. So the two lines, that is the mirror line and the line that is passing through the object and the image, they are perpendicular, they are orthogonal. So we can say that the product of their gradients is equals to negative 1. All right, so we know that the gradient of the mirror line is 2. So 2 times m2 is a negative 1. So it means m2 is negative 1 over 2. All right, so we already know that one of the points is this. So we can determine the equation of that line, because this is 2, negative 3, and its gradient is this, very quickly. So y minus 3, that's plus 3, over x minus 2 is equals to negative a half. So to get this equation, you can multiply both sides by 2, and then the other side you cross multiply, by the way, so that you determine that. So you have 2y plus 6 is equals to minus x plus 2. And so this equation is equal to y is equals to minus a half x minus 2. All right, so if you divide by 2 and then you take this to the other side, it narrows down to y is equals to negative a half x minus 2. So this is the equation of this line joining the object, that is point P, and its image somewhere here. We know for sure that the image will be on this side, probably somewhere here, because the distance from here to where the mirror is, or where the mirror line is, to where the image is they are equidistant from the mirror line. That's exactly what we already know. So what do you know? You know that when the two lines intersect, that is line y is equals to 2x minus 1 and y is equals to negative half x minus 2. When they meet, the point of intersection between the two lines is a solution to the simultaneous equation between the two lines. So, and that is very important because we shall use it now to get the midpoint, and that is the point where the two intersect. And once we get that, it will be very easy for us to get the image. Okay, so if you solve this equation 1 and 2 simultaneously, you will obtain that x is equals to minus 2 over 5, and that y is equals to minus 9 over 5. Well, that is something I know you can do when you solve this one simultaneously. You can use the elimination method, substitution method, or matrix method, whichever the case. So you solve that. And this point now, it is where the line, and I'm hoping that I can draw without a ruler there, where they are meeting. So they are meeting at a point. I'm calling this point, allow me to zoom in somewhere here, and I call this one negative 2 over 5 comma negative 9 over 5. So where they are meeting, that is the point of intersection, which is a solution to the simultaneous equation we already have here. So this is the midpoint. Now, how can we use now the midpoint and the object to get the image? That's very easy. The concept of midpoint can be applied here. It's very easy. We can say, let the image P prime be HK, all right? Be HK. So we say that H plus 2, this 2 here, over 2, the midpoint is going to be negative 2 over 5, right? So for H, H from here, you can see it is negative 4 over 5 minus 2, all right? So actually this gives you H is equals to minus 14 over 5 from here. You can use your calculator very quickly. Minus 4 over 5 minus 2. That is negative 14 over 5. That's cool. So again, to get K, you can say K minus, okay, you know it is plus minus 3, so it still be minus 3 over 2 is equals to the coordinate, the y coordinate, that is negative 9 over 5. So K is equals to negative 3 over 5. So we have successfully determined the value of our P prime somewhere here, which is negative 14 over 5 comma negative 3 over 5. Right? So to actually give the solution to this, P prime is negative 14 over 5 comma negative 3 over 5. Thank you.